ChatGPT is based on the Langauge Model GPT-3, or more precisely GPT 3.5. GPT stands for Generative Pre-trained Transformer. It's a type of large language model that is trained to generate human-like text. It is based on the transformer architecture, a type of neural network that is particularly well suited for natural language processing tasks. In the rest of this episode, you're going to hear words like model, training, natural language processing, and neural network a lot, so it is very important to understand these concepts to comprehend how ChatGPT works. Natural language processing is a field of computer science and artificial intelligence that deals with the interaction between computers and human languages. It involves developing algorithms and systems that can understand, generate, and analyze human languages such as speech and text. A language model is a type of computer program that helps us understand and analyze a language. A well-trained model is good at figuring out the meaning of words and sentences, and it can even translate words from one language to another. Training in the context of the language model is the process of teaching a computer program to do a specific task. For example, to teach the model or a computer program to understand and analyze text, we give the program lots of examples of text to study, such as books, articles, and websites. The program will look at all of these examples and try to figure out the rules of the language, such as what words go together and what those words actually mean. What is neural network? A neural network is a type of computer program that is really good at solving problems and learning new things. It is called a neural network because it is inspired by the way the human brain works. Just like the brain has a lot of tiny cells called neurons that are connected together and work together to help us think, a neural network has lots of tiny computer programs called neurons that are connected together and work together to help it solve problems. To train a neural network, we give it lots of examples of the problem we want it to solve. For example, if we want the neural network to recognize different types of animals in pictures, we might show it lots of pictures of animals and tell it what kind of animal is in each picture. The neural network will try to learn from these examples and will become better and better at recognizing different types of animals as it sees more and more examples. Now that we have covered some fundamentals, let's get back to ChatGPT. ChatGPT is based on the transformer architecture. The transformer architecture is a type of neural network that is particularly well suited for natural language processing tasks. It was introduced in the paper Attention is All You Need by Vaswani et al. And has since been widely used in a variety of natural language processing and machine translation tasks. One of its key features is self-attention mechanism. Self-attention mechanism allows the model to weigh the importance of different input elements such as words or phonemes when generating output. Let's begin by looking at the model as a single black box. In a machine translation application, it would take a sentence in one language and output its translation in another. The transformer essentially is encoder and decoder component with a connection. The encoder's inputs first flow through a self-attention layer, a layer that helps the encoder look at other words in the input sentence as it encodes a specific word. The output of the self-attention layer are fed to a feed-forward neural network. The decoder has both these layers, but between them is an attention layer that helps the decoder focus on relevant parts of the input sentence. Say the following sentence is an input sentence we want to translate. The animal didn't cross the street because it was too tired. What does it in this sentence refer to? Is it referring to the street or to the animal? It's a simple question to a human being, but not as simple to an algorithm. When the model is processing the word it, self-attention allows it to associate it with animal. As the model processes each word, self-attention allows it to look at other positions in the input sequence for clues that can help lead to a better encoding for this word. Let's see the use cases of self-attention. When translating a sentence from one language to another, self-attention mechanisms might allow the model to pay more attention to certain words or phrases that are more important for understanding the meaning of the sentence. For example, if the model is translating sentence from English to French, it might give more attention to words like the, and an, which are important for determining the grammatical structure of the sentence. When generating text that is similar to human written text, self-attention mechanisms might allow the model to pay more attention to certain words or phrases that are important for capturing the style or tone of the text. For example, if the model is generating a news article, it might give more attention to words like said, according to, and reported, which are commonly used in news writing to attribute information to sources. When analyzing the sentiment of a piece of text, self-attention mechanisms might allow the model to pay more attention to certain words or phrases that are indicative of the overall sentiment of the text. For example, if the model is analyzing a movie review, it might give more attention to words like amazing, terrible, and disappointing, which are strong indicators of positive or negative sentiment. Alright folks, that's it for today. I hope you learned something from this episode. For more content like this, please like and subscribe. If you have any suggestions for future episodes or you want to share your thoughts, please don't hesitate to reach out to me on Twitter. You can find the details in the description. Until next time, take care and have a great day.